Hello and welcome to our presentation of the FODbot. Our team name is the Resistance. Our team members include Cade Nokes, Brian Hebert, myself, Daniel Moody, and Michael Baucum. Our problem statement: when working in a shop, small pieces go missing often and they are difficult to find. A lot of times when we were all serving in the military, we found that we wasted a lot of man hours looking for these small parts, and we decided to design a robot that could do it for us. The end user would be government agencies such as the Navy, Air Force, Marine Corps, and Army. And then here's some of the interviews that we conducted and found that most of the answers to the questions were generally the same. Some of the criterias are that the robot can find small parts, it's able to sense obstructions, is self-automated, can run for an hour, and is easily repaired by the customer. And then this is one of our these are our CAD designs.
Hi, I'm Brian Hebert. I'm an electrical engineering major here at ASU, and I'll be going over these next few slides. The first one I want to go over is the functions of the car as I actually have it. As you can see, it's been designed to move the motors out of the way. They can also rotate, etc. Another one is we have two Arduinos in the car, one for mainly the motors and the spinning, and then one of them for driving the car itself. We have a magnetic bar, line sensors, and then 3 battery packs on this vehicle to get it to go. Some of the important and unique features on this vehicle are the brushes, which will funnel any hardware towards the magnet found underneath, as well as the line sensors. This way it can follow a designated path that you decide, or it also has its own free roam mode where it will avoid collision, as well as a remote control mode if that's something you'd rather do. Just a snippet of our coding. We used a switch case statement, 4 main switch cases. One of them is motors down, motors up, and then brushes on, and then a complete kill switch to save power and to turn the machine off. Some of the main design changes were we moved the servo motors with the brushes up as there wasn't enough clearance as it was originally designed on the lower level. And another one is we had a detector on the bottom towards the magnet that would notify you whenever it would pick up anything. We felt those were bad. That was a bad choice because it would give you a lot of false positives as well as not enough clearance under the vehicle. Here's our part listing. The car kit came with the majority of it. I also had a couple of parts on hand, but ultimately it's a very inexpensive vehicle and very easy to reproduce, but I think a more refined version would cost more in the end. This is the work division between the team. Cade did a lot of the building. I also did a lot of the building. I did all of the coding. Me and Cade did a lot of the testing and troubleshooting as we're the ones with the vehicle. Daniel was the CAD expert and he put all the CAD parts together and we all contributed to the CAD parts.
Hello, my name's Cade Nokes. I'm an electrical engineering major, and I'm here to talk to you a little bit about our FODbot here. So what else is out there? There's a FODbot. It covers a large area quickly. It picks up non-metallic as well as metallic items, but it has quite a few weaknesses. It's difficult to set up. It can't get underneath an aircraft out on the flight line, and it also can't be used indoors. It can't be used in inclement weather, and it exposes the vehicle to tires that can be punctured by items out on the flight line. Another item that's out there is the Roomba. The strengths of this would be that it can be charged. It's self-automated. It can empty its own contents. It can retrieve metallic and non-metallic objects, but it has a few weaknesses as well. It cannot follow a designated path. It cannot be used in wet conditions because it would damage the vacuum function on it, and it shouldn't be used outdoors, so that would affect it quite a bit to be used outdoors. So the benefits to using the FODbot would be that it collects and retains missing pieces, such as screws and sockets that are dropped, things like that would cause time to be taken away from employees. It autonomously searches for missing parts that need to be accounted for, and it allows the employee to continue working after they just turn it on and it starts going through its routes to find these objects. It has the ability and will be able to save countless man hours, so the employee can keep working as well as the FODbot just continues to find the object that was lost, and it ends up saving the company money as well as the employee's time. In summary, the FODbot saves man hours. It works great in small shops and around a parking apron. It finds small pieces, stores them to prevent loss of man hours and damage to the aircraft, saves companies money by keeping their employees working on the task at hand, and it meets all the desires of all of the people we have interviewed for this. During the design process, there's a lot of lessons learned, such as that digital automated drawings will frequently change when real life is put out there. During testing, troubleshooting, sometimes desired functions is a lot harder than you would think when you get in hands-on with it. I mean, you can think of anything on a piece of paper, but when it comes to building it, it's a little bit tougher. Problems will arise constantly, no matter how you design it. When a member doesn't pick up their slack, it puts a lot of pressure back on everyone else, and it takes quite a bit of time to brainstorm great solutions to problems, and it takes a lot of ideas to make one good idea that'll actually function, and communication is key to success. For our project, we had a couple references, and these are the 3 for them.
Hi, I'm Michael Baucum. I'm a software engineering major here at ASU, and I'll be providing you with an in-depth functionality overview of the FODbot, as well as a demonstration of our functioning prototype. The FODbot is controlled with a remote, but it can also be set up with Bluetooth, so there is potential for a mobile application as a means of controlling the FODbot down the road. The user can control the FODbot manually using the arrows on the remote depicted here, or they can choose one of the FODbot's modes. The FODbot comes equipped with 2 main modes, the first being its line tracking mode, and the second being its obstacle avoidance mode. Alright, so let's talk about the line tracking mode of the FODbot. The line tracking mode of the FODbot in its current configuration uses the infrared sensor mounted on the bottom of the FODbot to detect a black line. In our demonstration, that line is going to be electrical tape. The black line that is currently being used, it's currently being used as a rail, in the sense that the FODbot will follow the black line as its designated path. It uses information from the infrared sensor to detect where the black line is, and it maneuvers accordingly to stay on that black line. Another application for this could be defining a border for the FODbot. So then it only operates within those black lines, and when it comes in contact with the black line, it will turn away. This is especially useful if the FODbot is only needed to operate in a small defined area. Here's a video demonstration of the FODbot's line tracking mode. The obstacle avoidance mode of the FODbot is where the FODbot roams autonomously, using the ultrasonic sensor mounted on the front of the bot to detect walls and other objects and move accordingly. This feature will save the most time for our intended audience, as it will run in the background with the sole purpose of picking up those small parts, saving man hours. Let's see it in action.
I'm driving right now. Do you want to try on the fence brushes?
Yeah, go for it.
Maybe.
There you go, brushes are on. See if we can get those screws. There we go. You gonna go wall avoidance? Sweet. Nailed it.